Hey, grade nines. So welcome to our next lesson. So we're on lesson 5 of unit 8. This is the second last lesson, so we're almost done here. So we're going to go over volume and surface area of a sphere, which in my opinion is a little bit easier, actually quite a bit easier than dealing with pyramids and cones. I think you saw in our examples with pyramids and cones, there's a couple more little details to it, and sometimes we have to work backwards to figure out what the perpendicular height would be or the slanted height would be if you're finding the surface area of a cone. It just gets a little bit more tricky sometimes, and there's more details to it. And even the surface area of a pyramid, there's not necessarily one formula that fits all of them. So you really have to kind of break it down by step. Luckily, volume and surface area of a sphere is actually quite easy. It works all the time. Really, all you need in this case is radius, which makes it a lot simpler. So let's just start off easy. How do we find the volume of a sphere? Well, we know that the volume, the first thing we'll kind of know is that the volume of a sphere is 2/3 of the volume of a cylinder that it fits inside of, right? So if we can picture, sorry, I'm just getting a pen here. If we can picture that we have a cylinder like this, and we have a sphere that fits perfectly inside of it. Let's just assume it fits perfectly inside. Let's assume that the drawing actually is good. We can actually see here that it would be approximately 2/3 of the sphere itself would be 2/3 of the cylinder, and that kind of makes sense because obviously it's not gonna there's gonna be kind of missing gaps when we put that sphere inside of the cylinder there. So keep in mind that this is a case that this is one of those things that you probably should visualize. And if we were in class, I would actually show you exactly what this looks like. But unfortunately, it's not going to be the case for the cohort A. So you can if you can kind of visualize this, and you can actually maybe see pictures of this, where if you have a sphere, if you compare a sphere to a cylinder that it fits into perfectly, you would notice that the sphere itself would be 2/3 of the cylinder that has the same radius and the same height. So how does this help us? Well, if it's 2/3 of the volume of a cylinder, well, luckily we know what the volume of a cylinder is. The volume of a cylinder is pi r squared times height. So we are also told that it has the same radius and the same height. Now, going back to basics here, in a circle, we might notice that the radius itself, and actually let me switch back to blue, the radius itself right here is also going to be is basically the distance from the center to any point on the circle. If we actually combine it together with from one end to the other, we'll actually notice that that creates the height of the whole entire cylinder there. So that means that the height of the cylinder, which is the same height as a sphere, would just be 2 times the radius. So that's our next big observation here, that the height of the cylinder is simply going to be twice the radius. So because it's going to be twice the radius, because we can kind of see here that the height is simply from one end of the sphere to the next, which is 2 times the radius, then we can replace the height itself with 2r. So we replace the height right here with 2 times the radius. And of course, now we notice that we can simplify this a little bit more. It doesn't maybe look that way, but we can, because we have constants here. We have coefficients that we can multiply together. So we take 2 times 2/3 times 2. 2/3 times 2 is 4/3. And then we have pi multiplied by itself. And how do we get the r cubed? This is a really good question. Well, r cubed we're getting from, just going back to basics, we have r squared times r. And we know that r squared times r ends up giving us r cubed. Remember, this is imaginary exponent 1. So we just add them up and we end up getting r cubed. So this is how we actually get our volume for the sphere. Now keep in mind, I'm never going to ask you on a test how did we come up with the volume of the sphere. You just need to know how to use it. But I just like to show you how we came up with that. So don't stress if this didn't really make a lot of sense. All you need to know is how to use the actual formula. So the volume of the sphere, again, with the sphere, we know that we are going to be having a cut radius, which is basically the distance from the center of the sphere to any point on the sphere. So to calculate the sphere, we are simply going to take 4 times pi times the radius cubed And what the radius cubed means, just so everyone's clear on this, is radius times radius times radius. Do not confuse this with 3 times radius. That's not the same thing. So don't confuse that. So this is not correct. This is what we're looking for. Radius times radius times radius divided by 3. And alternatively, there's a slightly different way I can do this. I can actually write this as 4/3 times pi times r cubed. I feel like most people prefer to write it as 4 pi r cubed divided by 3, but you could also think of it as 4/3 times pi r cubed. It's the exact same expression there. So let's look at an example here. What's the volume of a ball with a radius of 3 centimeters? So if the radius is 3 centimeters, we let r equal 3. And what we're going to do is we're simply going to take our formula, and instead of writing 4 times pi times radius cubed, we're just going to, and divided by 3, we're just going to replace the radius right here with 3. So we replace the radius with 3, and this ends up giving us 4 times, and actually I'll show you steps here, 4 times r cubed, which is 27. We then multiply 4 times 27, which ends up giving us 108 pi. And again, and notice, just like we talked about in the last example, I would suggest just not actually multiplying by pi yet. Just keep working with pi, keep this pi symbol throughout all the calculations until the very end. So then I end up getting 108 pi divided by 3. And of course, 108 pi divided by 3, I can reduce it by simply dividing 108 by 3, because 108 and 3 are like terms, so we can, are numbers, right? So we can divide them like normal. This kind of goes back to unit 2 when we talked about simplifying expressions. So 108 divided by 2 gives us 36, and of course I still have pi by itself, so I leave it as 36 pi. And that means that my total volume there is 113.1 centimeters cubed. So that is the volume of my sphere here. So keep in mind that I decided in this question to kind of treat it as treat the whole answer in terms of pi instead of actually treating it as a number. And I basically only switched it from pi to a number until the very last step. And again, the reason you do this is so that you get a more approximate answer. So at the very end here, we take 36 and we multiply it by pi. And we know that 36 multiplied by pi would end up giving you 113.1 centimeters cubed rounded to 1 decimal place. So this really does, I know that some people kind of look at this and say, well, isn't it easier just to multiply by 3.1 for right from the beginning? Well, to be honest with you, you could do that. But I just find, this is just my personal opinion, I feel like in the end, then you're going to have to be rounding throughout. And that gets a little more frustrating. So if I had left it as 4 times 27 times 3.14, I would have to take 4 times 27, which is 108, times 3.14, which I'm going to grab a calculator because I don't know how to do that calculation right off the top of my head here. So I have 108. I just kind of want to show you that it does take quite a bit longer. 108 we multiply by 3.14, which ends up giving us 339.29. And now, technically in this next step, you would have to write down the number on a paper or keep it in your calculator, 329.29. And then you have to remind yourself, okay, don't forget, I have to divide by 3 next. And then you have to keep all these numbers stored in your calculator or write it down on a piece of paper. I personally think it's just much easier to simplify it first, leave pi until the very end, and then when you're done, multiply by pi. And that makes it a lot simpler. So again, that's just my suggestion. You don't have to follow it. And especially in grade 9, you're still learning how to do this. So we are definitely a lot more flexible in terms of how you leave the answer, but it is generally accepted that you're going to be working with pi. You normally sometimes just leave the answer as pi when you get to senior level grades. So just kind of keep that in mind. How do we find the surface area of a sphere? Well, I'm not going to go into too much detail here. Because of the timing of the course, we won't have a lot of time to actually go over why this necessarily works. But all you need to know for now is that the surface area of a sphere is 4 pi r squared. Essentially, if you were to picture a sphere, and I was thinking about the surface area around it, you know that a sphere is a 3-dimensional circle. So it's basically saying here that it would actually take 4 circles to fill up the area of the sphere. So if you're taking, if you're picturing like a ball and you're thinking, okay, well, how would I actually wrap it up fully without any remaining parts? It would actually take 4 times the area of the circle itself if it was in 2 dimensions to fill it up completely. So how do we actually use this? Well, we're going to actually, instead of doing an example where we're using surface area, I'm going to do an example that is a bit more challenging. This is one of those harder questions that tends to trick students a bit because there's a couple of parts to it. So how would I find the surface area of a sphere if I'm given the volume instead of the radius? This is where it gets tricky. So notice that in this example, I actually did not give you the radius. I, on purpose, gave you the volume just to kind of throw you off a little bit. It's a little bit different than the other questions. So because of this, we're gonna have to go step by step. So we are told right now that the volume is 50 centimeters cubed. How can we use this to help us figure out the surface area? Well, the hard thing with this is that to find the surface area, we need the radius, but there is no radius, right? That's what's missing here. So what you're gonna do is you're gonna use the volume to work backwards to figure out what the radius is. So what we're going to do first is start off with the volume. Well, we know the volume is 50 centimeters cubed, so we replace the volume with 50, and we make this equal to 4 pi r cubed divided by 3. This is just the volume of a sphere formula. So what I'm going to do next is I'm going to look at this and say, well, what's my goal? My goal is to find out what the radius is. That's what I want to know. If I know the radius, then I can easily find the surface area. So my next step here is I'm going to multiply by 3 on both sides. So multiply by 3 on both sides. Then this ends up giving you 150 is equal to 4 pi r cubed. And my next step here is I'm going to divide by 4 on both sides. And I divide by 4 on both sides. And actually, I can make it even simpler. Not only can I divide by 4 on both sides, I can actually divide by 4 pi on both sides, just to bring the pi over to the other side there. And this just eliminates the whole entire, all the coefficients of r cubed. And then I'm just left with r cubed by itself. So in this example, I'm just going to erase this just so we don't get too messy here. I'm going to take 150 is equal to 4 pi r cubed, and then of course I'm going to divide by 4 pi on both sides. And again, the reason I divide by 4 pi on both sides is just to get rid of the coefficient in front of r cubed. And now this becomes a lot simpler. Now, I already mentioned this. You could figure out what 4 times pi is, write the number down on a piece of paper, and then divide 150 by that answer. But I would say, you know what, just keep it as it is, keep it as 4 pi, and just figure out what this is on a calculator. So grabbing your calculator here, 150 divided by 4, and then divided by pi. That gives you the exact same answer. So keep in mind that taking 150, if you divide it by 4 and then you divide it by pi, that gives you the exact same answer if you put this in steps. Or you could take 4 times pi and then divide 150 by that answer. 2 different ways I can do it. In the end, this ends up giving me approximately 11.93. So then, again, keep in mind that in this case, I decided to round the 4 pi itself. And I end up getting 11.9, sorry, actually 11.94. Sorry, I forgot to round up. 11.94 is r cubed. And then of course, my last step here is I know what the radius cubed is. So I have to think to myself, all right, well, how do I get the radius by itself? Well, what is the opposite of cubing something? So this might be a little bit new to some of you. The opposite of cubing something is actually take the cube root. And this is a button that some of you might not be that familiar with. I think I mentioned from day one that you should have a scientific calculator with you, not one of the smaller ones where you don't have all the calculations. If you have I always call like the dollar store calculators, they don't work as well. I'll be honest. I've gotten calculators from the dollar store in the past, and there's a lot there. I find sometimes the functions are not all there. So if you may not have this button in your calculator, if you don't have it for whatever reason, I would definitely suggest either using a computer so you can actually look for this button. So I'm actually going to show you how to do this calculation on a calculator here. Just want to make sure everyone's kind of aware of this. So what I'm going to do is I'm going to take my answer, which was, and I'm going to start from the very beginning so I get a really accurate answer. I'm going to take 150, I divide by 4, I divide by pi, which is, sorry, I don't use this calculator as much. I'm more familiar with with the calculator I use here. So let me extend this out. And I'm sure pi is here. I'm just like not finding it here. Sorry. And sometimes it's literally staring at you right in the face. It's actually right here. So I am going to divide by pi right there. And then I end up getting 11.9366. And now you're looking for the cube root. Now, and if you have a Mac, I personally had a Mac before, and I can tell you, personally for this stuff, Macs are a lot better. If you don't have a Mac, that's okay. You might have to. I'm assuming you probably have the same calculator as me. You may have to switch to the second function there, and you're going to be looking for the cube root button, which is this one right here. So click on that button right there. And this, what it will do is it'll tell you what number is multiplied by itself 3 times to give you 11.93. And that answer is 2.2853, blah, blah, blah. So what I would do, because we're going to be using this, so notice that this answer right here is actually going to carry on to the next step. You don't want to round your answer too much. This is the error that people make. They sometimes take this answer and they say, okay, my radius is 2.2853907. And then what they'll do is they'll say, you know what, I'm getting kind of lazy. I'm going to make the answer 2. Don't round like that, right? Because especially we're not done the question, right? We have not finished the question. This answer is going to continue on to give us the surface area. So you really do not want to round too much. I would actually suggest, if you can, to round it to 2 decimal places or 1 decimal place at the most, right? You should not be rounding more than that. So if you were to round to 1 decimal place, it would be 2.3. If it was 2 decimal places, it would be 2.29. So you have 2 choices there. But I would personally not try to round the answer that much, or better yet, keep the actual answer that you have there. Do not delete it, because you're going to be using this for your next calculation. So in step number 2, or this is the next step of the whole problem, to find the surface area, we're simply going to take 4 times pi times radius squared. So in our case here, the radius is 2.29, which is actually a larger number than that. It's actually this whole number here. But we know that we're going to be squaring it. So sorry, going back here. So a lot of tabs open. You know you're going to be squaring this. So we're going to take 2.29 and we are going to simply just square it. So we have a square button right there, or you can just I was going to say multiply by itself, but to be honest with you, because it's a large number, you don't want to be writing it out again. So I would just press the square button on there, and then you're going to be multiplying this by pi. And so we go back here and we just double check. So we are taking r squared, so 2.29 squared, multiplied by pi, and then we multiply by 4. So going back to our question here, we are going to take this and multiply by pi. And then we multiply this answer by 4. And that ends up giving us 65.63 and rounded off. Now keep in mind that I think in this example, I actually may have rounded my answer myself, which obviously if I round my answer, then the whole answer is slightly off. So I believe if I had used 2.29 and then I square it and then I multiply by 4 and then I multiply by pi, I actually end up getting 65.9, which is this answer here. So keep in mind that the difference in the answer is because I rounded. But you really, like I said, want to try not to round that much, because even just this little bit of rounding that I did here actually threw my answer off by a little bit. And the more you round, the more errors you have, right? So you really want to be careful with that. Okay, so last example I want to go through, how do you find the volume of, how do you find the volume of that's remaining? So let's say we had a word problem here. So let's just take this step by step. So you have a soccer ball that's packaged inside of a cube shaped box. So what is the volume of the space that is not occupied by the soccer ball? So what I need to do in this case is I am simply going to find out what the volume of the sphere is. Start off with the sphere here. The volume of the sphere is 4 times 3.14 times the radius cubed. And of course, the radius cubed is 1,000. So going step by step here, and I didn't show all the steps because I'm hoping this is all pretty clear. You're going to take 1,000 times pi times 4. And I would actually just suggest writing 4 times 1,000 times pi. So put the numbers together, divided by 3, which actually becomes 4,000 over 3 pi. right? I can write it like a fraction. So put this in your calculator, 4,000 pi divided by 3. What does this give us? 4,000 pi divided by 3. I just want to show you how much of a difference it makes. Yeah, we end up getting the exact same answers, 4,188.79 centimeters cubed. So that is the volume of my sphere. The volume of my cube itself, the larger cube here, is quite easy, 20 times 20 times 20, which is 8,000 centimeters cubed. So if I want to find out what is remaining, what's the volume of the space that's not occupied by a soccer ball, I simply take the volume of the cube and I subtract off the volume of the sphere, which ends up giving me 3,811.21 meters cubed. And that's my final answer there. So just a couple of things before we end off, just a word of caution. When you're carrying out formulas for surface area or volume, just be careful with the order of operations. Like I said, I personally, my opinion, I think volume and surface area of a sphere are probably the easiest calculations you can do because you only need radius. That's kind of nice. But the tricky thing with this is that you still need to follow the order of operations. Sometimes people forget this. You don't forget, you always do powers first before you multiply, right? And keep in mind that sometimes you're given diameter instead of radius. So if you are given diameter instead of radius, remember you have to divide by 2 first. Also, another reminder, make sure you use the pi button in your calculator instead of actually rounding it to 3.14. This is just going to give you a more accurate answer there. And again, try not to round until the very last step. This is a big suggestion for you. I know it's very tempting to want to round answers, but you really want to try to avoid that as much as you can until the very last step. And if you can, I already mentioned this, do not multiply by pi and treat pi as do not multiply by pi until the end. So basically you're treating it as a separate variable. And again, this will just give you a more accurate answer. And as I mentioned already, make sure you actually use the pi button in your calculator, not 3.14, because that actually does make quite a big difference in the end. And that is it.